Now we go to molecular diffusion in solid. In solids, particularly, diffusion occurs due to thermally activated random motion of atoms, unless the material is at absolute zero temperature, which means 0 Kelvin. Individual atoms keep vibrating and eventually move within the material. One of the possible net effects of diffusion is that atoms move from regions of high concentration of one element to regions with low concentration until the concentration is equal throughout the sample. Because liquid and gas have more spaces between particles, thus particles can move and spin easily. As we know, diffusion can occur too, first, due to presence of concentration gradient, and two, increase in temperature.
In this section, we will learn how mass transfer through molecular diffusion or diffusion of gases, and we will specifically focus on how gas behave, and we will also focus on how smell spread. Let's get it over with. When we observe at atomic level, gas particles are spaced out to one another. These particles travel at high speed at random direction. It also takes shape of its container. For instance, smelly gases given off by rotting vegetables in a sealed container will fill the container with rotting vegetable smells, but we won't be able to smell them outside the container. However, if we remove the lid, these gas particles will start to escape and spread out of the container. This gas travels from high concentration region, in this case inside the container, to low concentration region, in this case outside the container. Soon, we will be able to smell the rotting vegetables, and this mechanism is what we call gas diffusion, and that's how smell spread. Under molecular diffusion, there are three cases. In equimolar counter diffusion, the mass transfer between two gases at constant pressure. They transfer through a tube connected to both gas chambers in steady state. In this case, net moles of A diffusing to B is same from net moles of B diffusing to A. Second case, diffusion of two gases plus convection. This situation happens when mass transfer occurs between flowing fluid, for example heat exchanger. Flux by convection consists of flux by diffusion and flux by advection, while the total flux is a combination of diffusion flux and convection flux. In case 3, fluid A diffusing through non-diffusing fluid B. As mentioned above, fluid A, usually pure liquid, will diffuse into non-diffusing liquid B, air for example. It happens due to surface of pure liquid that is impermeable to air. Therefore, air is insoluble in pure liquid. Thus, molar flux of air in pure liquid direction is 0. Only molar flux of pure liquid in air direction is measured. Example for case 3 is liquid resin diffusing through non-diffusing air. That's all from me. Thank you. Don't forget to like, comment and subscribe.